All right, two-way tables and probability, section 13.3. Our lesson objectives are to make two-way tables, find relative and conditional relative frequencies, use conditional relative frequencies to find conditional probabilities. So our central question is, how can you construct and interpret a two-way table? All right, making two-way tables. We're probably most familiar with one-way tables, and that's where we use data to create like bar graphs, histograms, and things like that. A two-way table is a frequency table that displays data collected from one source that belongs to two different categories. And then our joint frequency is the entry in the table. So each of these values, the 25 is a joint frequency, 44 is a joint frequency, 80 is a joint frequency, 32. So each value within each cell, so attending freshman would be 25. Each of these are joint frequencies. And then our marginal frequencies is when we add up the rows, so each row's total, and then each column's total. So let's just practice these new vocabulary words using the example 1, making a two-way table. In another survey similar to the one above, 106 juniors and 114 seniors respond. Of those, 42 juniors and 77 seniors plan on attending. So we can plug that into our frequency table. And then organize these results in a two-way table. So the two-way table is you've got your junior, senior, your classifications on the left, and you have your attendance, attending, not attending, across the top. And then rows and columns represent each of the class members, attending, not attending. So to find and interpret the marginal frequencies, we would need to take our totals. So there are 106 juniors total that we also know about, and 114 seniors. So we can just subtract and fill in the rest of our table. So not attending juniors would be 106 minus 42, which is 64. Not attending seniors would be 114 minus 77, which is 37. Then we can go along each column and add up our totals. So the total junior and seniors attending is 119. And then our total junior seniors not attending is 101. And then for each total column and total row, it should match at 220. So we found our joint frequencies in step 1. That was filling in each cell. The 42, the 77 were given, and then we subtracted to find the 64 and the 37. Our second step was finding the marginal frequencies. That's adding up each row and column. We found the sum of the marginal frequencies and placed the values at the bottom and at the right. And that's how you make a two-way table. Let's talk about finding relative and conditional relative frequencies. First, joint relative frequency. It's the ratio of a frequency that is not in the total row or the total column to the total number of values or observations. So it's a ratio. Marginal relative frequency, it's the sum of the joint relative frequencies in a row or a column. Conditional relative frequencies, these are the ratio of a joint relative frequency to the marginal relative frequency. You can find a conditional relative frequency using a row total or a column total of a two-way table. All right, our example 2 is finding joint and marginal relative frequencies. We're going to use the survey results in example 1 to make a two-way table that shows the joint and marginal relative frequencies. All right, so to find the joint relative frequencies, you need to divide each frequency by the total number of students in the survey. All right, so we'll start with our juniors who are attending. That was 42, and our total is 220 students. So we can take 42 divided by 220, which is approximately decimal 191. All right, next, let's take a look at our seniors attending. That was 77 out of 220, so that's about decimal 35. Now let's do our students not attending, so 64 out of 220, and then 37 out of 220. So there's our joint relative frequencies, and that's by dividing each frequency, remember that's the value in each cell, by the total number of students in the survey. Next, to find the marginal relative frequencies, you need to find the sum of each row and each column. So we add up our first column, and that comes out to be decimal 541. So you're adding the decimal 191 to the decimal 35 to get a total of decimal 541. You do that for each row and each column. And what we should see at the very, very end is the sum of rows and columns to be 1, which represents 100%. So we can interpret this information as, for example, in this not attending junior column, we have about 29.1% of the students in the survey are juniors and are not attending the concert. We could interpret this decimal 518 as it's about 51.8% of the students in the survey who are seniors. So each value has its own interpretation. So remember, to get joint relative frequencies, you take the number for each cell divided by the total, and that gets you your percent value. And then you add up the rows and columns, and these values, the total values, represent your marginal relative frequencies. All right, our next example, we're going to use the survey results in example 1 to make a two-way table that shows the conditional relative frequencies based on the row total. So let's start with our juniors attending. We take that decimal 191, which represented the joint frequency in example 2 for the juniors attending, and divide it by the row total for juniors, which was decimal 482. That value comes out to be approximately decimal 396. You do the same thing for not attending. The not attending joint frequency was decimal 291 divided by the row total for juniors, which was decimal 482. When you divide that, it comes out to approximately decimal 604. Now let's go to our seniors, which was decimal 35 joint frequency for seniors attending, divided by the senior total, which was decimal 518. Remember, you need to look at the previous example for joint and marginal frequency values to see where these numbers are coming from. So we can interpret these values to mean, like for seniors not attending, we can say, given that a student is a senior, the conditional relative frequency that he or she is not attending the concert is about 32.4%. So this is how you figure out your conditional relative frequency values. Okay, now we want to find conditional probabilities, and you can use conditional relative frequencies to find conditional probabilities. All right, here in this example, we have a satellite TV provider who surveys customers in 3 cities. The survey asks whether they would recommend the TV provider to a friend. The results, given as joint relative frequencies, in other words, we've already figured out all the values for the joint relative frequency, are shown in the table, two-way table. Part A, what is the probability that a randomly selected customer who's located in Glendale will recommend the provider? All right, here's how we want to set it up. We want the probability that yes, the provider will be recommended, and given it's in Glendale. So we are looking at the probability of Glendale and yes compared to the probability that it's in Glendale. So we take our two values, so decimal 29 is the yes Glendale. So yes Glendale, find that value, there it is, decimal 29 is in the numerator. And then we want the probability that it's Glendale. Well, there's two values for Glendale. There's the decimal 29 and there's the no from Glendale, decimal 05. All of these total need to be a part of the Glendale probability. So we figure that value out, and it comes out to be decimal 853. Now, what is the probability that a randomly selected customer will not recommend the provider is located in Long Beach? So we're looking at probability of Long Beach and no. So in the numerator, we want the no in Long Beach compared to the no. The no in Long Beach would be decimal 04. So when you're looking at your table, you want to go to the no, find Long Beach, and name that value, decimal 04 in the numerator. And then we need the total of no's. So it'd be the decimal 0.5, the decimal 0.3, and the decimal 0.4 sum in the denominator. And that comes out to be decimal 333. Our last question is, determine whether recommending the provider to a friend and living in Long Beach are independent events. All right, so we're going to compare Long Beach, which is decimal 32 plus decimal 0.4 equals decimal 3.6. Now, let's see. We want to look at Long Beach and yes. And that's a decimal 3.2, and then compared to the probability of a yes. And that's going to be decimal 2.9 plus decimal 2.7 plus decimal 3.2, which comes out to be decimal 3.6. So because the probability of Long Beach is approximately the probability of Long Beach given yes, then the two events are independent. Then our last example, comparing conditional probabilities. We've got a jogger that wants to burn a certain number of calories during his workout. He maps out 3 possible jogging routes. For each workout, he randomly selects a route and then determines the number of calories he burns and whether he reaches his goal. So the table shows his findings. Which route should he use? All right, so he did some tally marks over here. We can see route A, B, and C. He reached his goal, tally mark number of times, and did not reach his goal, tally mark number of times. So we need to create a frequency table. So step 1, use the findings to make a two-way table that shows the joint and marginal relative frequencies. There are a total of 50 observations in the table. All right, so after doing a quick total of all the tally marks and then adding up all the rows, adding up all the columns to get a grand total of 50, we can now create our frequency table. So across the top, we'll have the results of reaching the goal and did not reach the goal, and then along the left side, we'll have the 3 different routes. And then we have our totals. So to reach the goal and did not reach the goal, we would get our joint frequency values, which reaching the goal route A would be decimal 2.2, and that's figured out, remember, with the 11 for reaching the goal route A divided by total is how you get the decimal 2.2. And then to get decimal 1.2, you take the 6 divided by 50 to get the decimal 1.2, add up each row, so the total for route A is decimal 3.4. So you fill in the rest of your frequency table with all the values for the joint frequencies and the marginal frequencies. Now we want to compare, find the conditional probabilities by dividing each joint relative frequency in the reaches goal column by the marginal relative frequencies in each corresponding row. So for reaches goal route B, we have the route B and reaches the goal divided by route B. So that's decimal 2.2 divided by decimal 3.4, result of decimal 733. Then for route C, we have route C and reaches the goal, decimal 2.4 divided by decimal 3.6. For route C, decimal 667. And I forgot about, I'm going to shift my totals up a little bit so we can see route A. Route A and reaches the goal is decimal 2.2 divided by decimal 3.4. So based on the sample, the probability he reaches his goal is greatest when he uses route B. So he should use route B. And that's all for frequency tables. We will practice in class tomorrow. See you then.